Alright, let's try finding a cubic zeros. We'll both solve it and we'll find it using synthetic division. The trick here, though, is before we can do synthetic division, we're going to need to find a factor that works. That is, we can't start dividing anything until we know a factor that works. So what we'll do is use factor theorem. We'll try some x's until we find one that goes into this equation. We'll try x equals 1, for example. We'll know it's a factor if we get the left-hand side to be 0. That'll mean that this is actually a 0 that can become a factor that we can use for synthetic division. Alright, well, when we try x equals 1, that's 1 cubed, that's just 1, minus 8 times 1, minus 3 times 1, plus 90. And it's pretty clear right away that these negative terms aren't going to add up to 90. It's not going to be 0. We should go bigger. Let's try x equals 3. Well, 3 to the power of 3, that's 27, minus 3 squared, so that's negative 8 times 9. And then we get minus 3 times 3. Oh, that's 27. You can probably write that as 27. Plus 90. But I can tell that one's not going to be equal to 0 either. You can try on your calculator, but I can see this is negative 72. This is negative 27, so they won't equal. But I'm getting closer a little bit. I could try a bigger number. What about x equals 5? We'll try a bigger number. Well, 5 to the power of 3, that's 125, minus 8 times 5 squared. Well, I can write 5 squared as 25, minus 3 times 5. 3 times 5, that's 15, plus 90. That one looks close. Let's check it on the calculator. Alright. 125 minus 125 minus 8 times 25, negative 75. Oh, that's good. Negative 15 plus 90. Sweet. Equals 0. Okay. So we have a factor. That is to say, x equals 5 is going to work for synthetic division. If we were using long division, we'd have to use x minus 5. But we're using synthetic division, so we'll now go into synthetic division. We write down the coefficients of the polynomial, and we put our 0 out in front. Now go through your synthetic division steps. Bring the 1 down. Multiply. 5 times 1 gives 5. Add. Negative 8 plus 5, negative 3. Multiply. 5 times negative 3 is negative 15. Add. Negative 18. Negative 18 times 5 is negative 90. Add. And sure enough, remainder 0. Remember, this last 0 is our remainder. This negative 18 is our constant term. The negative 3 is our x. And the 1 is our x squared. So, we have, don't forget the 0 term. We have x minus 5, that's our 0 of 5, gives this factor, times x squared minus 3x minus 18. That's our new left side of that equation. But we can continue on and factor this polynomial using, it's a quadratic, so we can factor it. Let's do that on the side here. Factor x squared minus 3x minus 18. We're trying to find something that multiplies to negative 18 and adds to negative 6. Well, that adds to negative 3. Well, those two numbers kind of gave it away there. What multiplies to negative 18 and adds to negative 3? Negative 6 and positive 3. So we can come back over here and say, look, this polynomial further breaks down. A quadratic becomes x minus 6 and x plus 3. Great. Now we've broken it down into 3 binomials, which is enough to go ahead and solve. So let's come up to the side here and solve. X minus 5 times x minus 6 times x plus 3 equals 0. So separate it into three pieces. X minus 5 is 0, or x minus 6 is 0, or x plus 3 equals 0. And now just move those pieces to the other side of their respective equations. We get that the solutions could be x equals 5, or x equals 6, or x equals minus 3. Therefore, the solutions are x equals negative 3, 5, or 6. And that's it.